The question is, a population is described by the dE, dP on dt is equal to 0.08 p times 1 minus p on 1,000, where p of 0 is 100, time being measured in months. And then there's 5 parts, A, B, C, D, E. And part A is write down the solution and sketch its graph. Okay, well, write down tells me that I should be able to just use some kind of formula to just write it down. I don't have to do any working. So let me just look up an equation that looks like that. That looks to me like it's a logistic equation. So let me write down what I know about logistic equations. So logistic differential equation is this: dP on dt is equal to kp 1 minus p over L, and the solution is p is equal to L over 1 plus a e to the minus kt, where, let's see, k is a constant, L is the, what's L? Let's have a look at that too. L is the limiting population. And K, A is a constant too, which I would have to find by subbing in t equals 0. Okay, so my problem, I've got dP on dt is equal to 0.08 p, 1 minus p over 1,000. And so k is 0.08 and L is 1,000. So I get p is equal to 1,000, because that's L, over 1 plus a e to the minus 0.08 t. And I just need to figure out what a is, but I can figure that out because I know what p of 0 is. So p of 0 is equal to 1,000 over 1 plus a e to the minus 0.08 times 0, and that comes out to 100. Okay, so start a new page. So what did we have? 1,000 is equal to 1,000 over 1 plus a e to the 0 is equal to 100. But of course e to the 0 is 1, so we get 1,000 over 1 plus a equals 100. So we get 1,000 equals 100 1 plus a, multiplying both sides by 1 plus a, which is 1,000 is equal to 100 plus 100a. So 900, subtracting 100 from both sides, is equal to 100a. So a is 9. And therefore, my equation comes out to, so therefore p is equal to 1,000 over 1 plus 9 e to the minus 0.08 t. Okay, and the graph of that, which I've been told to sketch, well, I know what a logistic graph looks like. It always looks the same. So there's p and there's t. When t is 0, it's 100. And then it slowly goes up towards 1,000. So there's 1,000. And my graph does that. That's what the graph looks like. So now let me do part B. B. Find the population at time 40 months and 80 months. So that would be t equals 40 because t is measured in months. So P would be equal to 1000 over 1 plus 9e to the minus 0.08 times 40. Which when I sub all that in my calculator, making sure that I put brackets before I divide, that comes out to 731.6. So at 40 months, the population is approximately 732. Alright, and at t equals 80, P is equal to 1000 over 1 plus 9e to the minus 0.08 times 80, which is approximately equal to 985.3. So at 80 months, population is approximately 985. Alright, what about part C? What is the limiting population? Well, I already wrote that down. The limiting population is 1000. And you can see that actually from the graph as well. If you look back at the last page, when I drew the picture, the way that this formula works is that the function will approach the line where L is. And you can see that as well. As t goes to infinity, e to the minus t approaches 0. And so this part becomes 0 and we get 1000 over 1. So the limiting population must be 1000. So limiting population is 1000. Okay. When is the population growing most rapidly? Alright, well, let me just look up my notes. Look, there's a theorem for this. It says that the population grows most rapidly when P is equal to L on 2. Let me just have a look at the graph there. So when you get to 500, that's when the most rapid growth happens. Oh, that looks about right. The steeper slope seems to be there. I can believe that. So most rapid growth occurs when P is equal to L, which is 1000 on 2, which is equal to 500. So I would need to solve that for t to find when it's the most rapid. So let me start a new page to do that. Right, so let's see, 500 is equal to 1000 over 1 plus 9e to the minus 0.08t. So we get 500, 1 plus 9e to the minus 0.08t is equal to 1000. So if we divide both sides by 500, we'll get 1 plus 9e to the minus 0.08t is equal to 2. So 9e to the minus 0.08t is equal to 1. So e to the minus 0.08t is equal to a ninth. So if we do logs of both sides, we'll get minus 0.08t is equal to ln of a ninth. And so t is equal to ln of a ninth over minus 0.08, which is approximately equal to 27.5. So most rapid growth occurs at 27.5 months. Okay. Well, that would leave part E, wouldn't it? Part E says, at what time does the population reach 900? Okay, well I just need to put population as 900 in my formula. 1000 over 1 plus 9 e to the minus 0.08t. So I could times both sides by the 1 plus 9 e to the minus 0.08t and divide both sides by the 900. Thousand over 900. So we get that. So we take 1 from both sides and we get 9 e to the minus 0.08t is equal to 10 ninths minus 1. 10 ninths is 1 and a ninth, so that's that. So e to the minus 0.08t is equal to 1 over 81. So minus 0.08t is equal to ln of 1 over 81. So t is equal to ln of 1 over 81 divided by minus 0.08, which is approximately equal to 54.9. So population reaches 900 after 54.9 months. And that's the end of the question.